Hello students, welcome to the 11th session of sets. In the previous session, I have discussed with you first 5 questions of the miscellaneous exercise. In this session, I will be discussing the questions from 6 onwards. Yeah? Now let's see the 6th question, what it says. It says, assume power set of A is equal to power set of B. Show that A is equal to B. Now when we are considering the power set, we know it very well ki what does the power set mean. So by taking that, we need to show this A is equal to B, and we know it the property of subsets ki if we prove that A is a subset of B and B is a subset of A, then we can say ki A is equal to B. This will implies that or not. So here we are considering, we are taking some arbitrary numbers or the values. So with the help of that, we are proving it. Here the condition is given that we need to take this. If the conditions are not given, we will talk about the conditions in the further questions also, where we can use the example. Now here we consider, let X belongs to A. What is X? X is an element which belongs to set A. Capital A it is there, so set A. So now further that we are assuming capital X is a subset of A. So what is a capital X? So here a small x is belongs to capital X. So capital X is a set and small x is an element which is a part of the set X, and here we are considering the X is a set which contains element X, and X is a subset of A. When A is a subset of A, that means that this X belongs to A which we have already taken it, so this X will be also a subset of A. Then further we can say X belongs to power set of A. How this X will belong to power set of A? So here we are assuming, I have written with a pencil, so here we are assuming let A is equal to 1 and 2, that's the element. So X is value as 1 and the capital X, that is a set X, will be 1 here. So now this X is a subset of A. That is, it will become what? It will become, this capital X will become a subset of A or not? So this will become subset of A. So here the power set, if we say, so it will have the empty set 1, 2, 1 and 2. The set will have it. So we can say X belongs to power set of A or not? This we can say. So here when we can say this, so here we can also say that set X belongs to power set of B, as it is given here that power set of A is equal to power set of B. So this we taking it. So here we said X, set X belongs to power set of B. So we can also say that the X is a subset of B, as X was the subset of A. So here we can say X is a subset of B. So if X is a subset of B, then element X also belongs to B, isn't it? So when it belongs to B, so we can say A is a subset of B. A set A which we have taken, so this is a subset of B. Now similarly, what we'll do, we will prove that B is a subset of A. So now we take Y as the element. When we are taking Y as the element which belongs to B, so then we can say this set Y, capital Y we are taking as a set Y is a subset of B. When set Y is a subset of B, then set Y belongs to power set of B, isn't it? So Y belongs to power set of A when we are saying that the power set of A is equal to power set of B. So here we can say Y is a subset of A, then small y element belongs to A. Okay, that's set A. So we can say by this B, set B is a subset of A. On these two conditions we can say that A is equal to B. I hope this is clear. Okay. So now this one thing you need to keep in mind, when we are using X and Y as the element, so we are considering certain things. We need to imagine that the elements are present in the set. Every time we will not do the proving by taking the examples. I hope this thing is clear. Now we move to the next question. Question number 7. It says, is it true? It says what? Is it true that for any sets A and B, power set of A union power set of B is equal to power set of A union B? Justify your answer. Example. So if we are taking the example, we just take it as A is equal to 0 and 1 element it contains, and B contains 1 and 2 element. So here A union B will contain 0, 1 and 2. Now this question can be done with very simple way. Taking the example, so we will write down the power set of A. So we will get these sets in the power set of A, and here the power set of B will be these, that is empty set 1, 2, 1 and 2. And if you say that A union B have taken, so what will be the power set of this? The power set of A union B will be your empty set 0, 1, 2, 0, 1, 0, 2, 0, 1, 2, 0, 1, 2. So here the number of elements, if you see in the power set, or number of subsets or power set, that will be your 8. And when we are doing the powers union of power set of A union power set of B, so here we get the total as the 6 elements. The 6 elements again, so we can say that the power set of A union power set of B is not equal to power set of A union B, as the cardinal numbers or the number of elements present or subsets present in the power set of A union B, that is your 8, and in cardinal numbers of the power set of A union power set of B is 6. So here this statement we can say that is power set of A union power set of B is not equal to power set of A union B. I hope this thing is clear. Okay, so now we move to the next question, that is your question number 8. What it says, now here it says to show that for any sets A and B, show that for any sets A and B, here A is equal to A intersection B union A minus B, and A union of B minus A is equal to A union B. Now here again it says for any sets of B. So here the condition is not given. Keep that we are by the rules of set, then we have to take it. So here also we can take the example, but I am explaining you with the not with example but assuming method of the elements. So here we have to show that to show this A is equal to A intersection B union A minus B, this we are equal to, remember that in the previous in the 6th question we have taken for proving that B is equal to C, B this for if it is B is equal to C, so what we have to prove, we need to prove that B is a subset of C or C is a subset of B. When we prove that, it implies that is equal to, the same way here we need to show this कि A is a subset of A intersection of union A minus B, and A intersection B union A minus B is a subset of A. This is what we have to show it. So here we are taking X element, X belongs to A intersection B union A minus B. So here this element is belonging to the intersection of A and B and union of A minus B. Okay? So here we can say that either when where union is there, so we can say कि X belongs to A intersection B or X belongs to A minus B. If X is belonging to A intersection B, so we can say X belongs to A and X belongs to B. And on this side, right hand side, you say that X belongs to A and X does not belongs to B. When we are having this A minus B situation, so we can write down all the elements of A which are not present in B. So here we say that this X belongs to A minus B. So here X will belong to A and X will not belong to B. I hope this thing is clear. So here we say X belongs to A, and here also we say X belongs to A. So if we see both the condition here, So we can say x belongs to A. So when x belongs to A, so here we started with what? We started the assumption with that we have taken that x belongs to A intersection B in union A minus B, and we reach here and we are proving here that is A intersection B union A minus B is a subset of A. This we have proved the first statement, we have shown it. Now we will show the second statement saying let y is the element of A. Now here we will take the another element, that is y, which belongs to, we will not take it as x. So here we are taking y belongs to A. So y belongs to A, so y belongs to B, or y does not belongs to B. We can say or not. So when y belongs to B, so here if we say that y belongs to A and y belongs to B, so we can say that y belongs to A intersection B. And when I say that y does not belongs to B, so then we can say that y belongs to A minus B. Then only the condition it will be here. No? And when it says that y does not belongs to B, so then it will say that y belongs to A. So when y belongs to A and here y belongs to A intersection B, so it's decide what? Y belongs to A intersection B or y belongs to A minus B. So when it says that y belongs to this condition, so we here say that y belongs to A intersection B union A minus B. So A is a subset of A intersection B union A minus B. So by the both the statement, so this will be the second statement. So by 1 and 2, we can say A is equal to A, that will be A intersection B union A minus B. This is what we were supposed to show it. Now we take the second part. The second part says prove that A union of B minus A is equal to A union B. That's what we are. So we need to prove what? We need to prove that is your A union B minus A is a subset of A union B, and A union B is a subset of A union of B minus A. So both the statement we have to prove it. So let us assume that X is belongs to A union B minus A. So this element X is belonging to what? It is belonging to this whole union of these two sets. This is a set and B minus A. So here we can say either X belongs to A, set A, or X belongs to B minus A. So when X belongs to this area, so here we can say either the X belongs to B, or but it does not belongs to A. So here we can say that it belongs to A and it belongs to B. So we can say further that X belongs to A union B. It says, isn't it? When it belongs to A and it belongs to B, so what will happen to the? It belongs to the union of both the set or not? So here we are writing it down. So and here it says, then we can say that A union of B minus A will be the subset of A union B. We started with what? We started with that element X belongs to what? Element X belongs to union of A and B minus A. So this has become the subset of A union B or not? So here we have got the first statement, and in the second statement you see that Y belongs to A union B. We are just moving the other way. So Y belongs to A union B. So when Y belongs to A or Y belongs to B. When Y belongs to B, so we can say that it does not belongs to A. Isn't it? So either it does not belongs to A. So when it does not belongs to A, so then Y we can say that Y belongs to B minus A. So when Y belongs to B minus A, so here we can say that Y belongs to A union B minus A. Yeah, or terms is what? So it says or not that union. So here we got the another statement that A union B is a subset of A union B minus A. This is the second statement. So here we can say by the statement number 1 and 2, that is A union B minus A is equal to A union B. I hope this thing is clear to you. Okay. So you need to remember, you need to feel that this, whenever you are using that X and Y that is belonging to the, we are talking about the elements of A or B. Now we take up the question number 9. Using properties of sets, show that A union of A intersection B is equal to A and A intersection of A union B is equal to A. Now in the both the cases that we are going to again use that same property. If A is a subset of B and B is a subset of A, so A is equal to B. The same property for the each cases we will use it. So first we will prove that this is a subset of A and A is a subset of A union of A intersection B. Let's take up this. The X belongs to arbitrary element X belongs to A. One more thing here, that we will not use any kind of an example here. We will be using arbitrary element as it says that by using the properties of sets. Using the properties of sets. So here we will be using this way. So X belongs to A union A intersection B. So X belongs to A or X belongs to A intersection B. The union stands for what? Or. So here we say, so here we can say that X belongs to A and X belongs to B. So in the both the cases that when we are having X belongs to A here, X belongs to A here, so we can say this X belongs to A. When X belongs to A, we started with what? A union, that's X belongs to A union of A intersection B. So this will be A, this will become the subset of A or not. Here we have got the first statement that A of union of A intersection B is a subset of A. Now we get the second statement that Y belongs to A. This is Y is also an arbitrary element that belongs to set A. So we can say that Y belongs to A union B. So A union B, so here reason that all the elements of A and B together we write it down. So if element of A is there, the element of A union B will be Y will also belong to A union B. Then we can say that Y belongs to A intersection of A union B. So here we have taken A. So this is A here. So Y will be again belong to the all those elements which will be common to A as well as A union B. So here we can say Y belongs to A intersection A union A intersection B. Here we have used the distributive property of intersection over union. So here A intersection A will become A and we will obtain this statement कि A is a subset of A union of A intersection B. Now here we have got the statement number 1 and statement number 2. With the help of this we can say that A union of A intersection B is equal to A. Now we take up the second part, A intersection A union B is equal to A. So again we are going to apply the same property. So here we are taking X as an element which belongs to A intersection A union B. So here we say X belongs to A and X belongs to A or X belongs to B. So here it is a union. So here we are using OR one. So from this here X belongs to A and X belongs to A. So we can say X belongs to A. So here we get the first statement that A intersection of A union B is a subset. Now we take the second statement, let Y belongs to A. When we take Y belongs to A, so we can say Y belongs to A union B. So all the elements of A union B, or we can say all the elements or Y as the element belongs to A, then it will belongs to A union B. So A union B is what? A union B is the all the elements which are present in A as well as in B. So here Y element belongs to A, so therefore it will belongs to A union B also. So here we can further say that Y belongs to A intersection of A union B. So A it belongs to A. When it belongs to A and it belongs to A union B, so then it will also belong to A intersection of A union B. So here we can get the second statement that A is a subset of A intersection of A union B. We started with that it belongs to A, so A will become the subset of this, isn't it? So with the help of the statement 1 and 2, we can obtain that the result A intersection B of A union B is equal to A. I hope this thing is clear. To understand these concepts, you need to see the video again, then you do the questions again on your own so that your concepts are clear. Now the 10th question says, show that A intersection B is equal to A intersection C need not imply that B is equal to C. Up till now that we have got the question where we say this, we say A intersection B and B intersection C show that it implies that A is equal to B. So here we have got three sets. One set is A, B and C, that we have got the three sets, and the relationship between them we need to prove, and it need not to imply that B is equal to C. So here we take for B is equal to C, we need to show that either B is a subset of C and C is a subset of B. We need to show this for proving this. Now we take it as, again we are using that arbitrary element that X belongs to B. So X belongs to B, so it may belong to A or it may not belong to A. This may be the condition or not. It may belong to A or it may not belong to A. If it belongs to A, then we can say that X belongs to A intersection B. If X belongs to B and X belongs to A, it may belongs to, so it may belongs to X intersection B or not. X belongs to A intersection B. And if it does not belongs to A, so it may not also belongs to X, may not belongs to A intersection B. So this is a condition. Here, if you see it carefully, so we just say that if we have the elements of B such and those elements belongs to A also, then it will belong to A intersection B. For example, if we say here that A, let's say X, suppose B, I take it as 1, 2, 3, 4, and if I take A as say 3, 4, 5. So here it is what? A intersection B, if we say that it is belonging or not. So if if this element does not belongs to A, so then it will not belong to A intersection B. So similarly we can say that X belongs to A intersection C as it is given here. A intersection B is equal to A intersection C. So here we are changing it. It is belonging to X belongs to A intersection B, so X belongs to A intersection C, or it may not belong to A intersection C. This is the condition. So here if it belongs to X belongs to C and X may not belongs to C. Are you getting it or not? So if it is belonging to A intersection C, so it will belong to C also. If it is not belonging to A intersection C, so it will not belong to C. So then we can say it will be a B is a subset of C and B is not a subset of C. We are getting the same condition or not? It may belong to this condition. So this we can say that a B is a subset of C or B is not a subset of C. This we can say it or not. So here we can have the another condition. If we take the another element, it says that other way we are proving it that Y belongs to A intersection C or Y does not belongs to A intersection C. If Y belongs to A intersection C, so Y belongs to A intersection B as it was given that A intersection B is equal to A intersection C. So here we say that if it does not, if it will not belong to A intersection B also, so it will belong to A. It will belong. Y will belong to B or Y will not belong to B. So here we get what? C is a subset of B or C is not a subset of B. So here we can say A intersection B is equal to A intersection C need not to imply that B is equal to C. So here it is both the condition it is coming. C is a subset of B and C is not a subset of B, and here we were getting B is a subset of C and B is not a subset of C. So here we are getting both the condition whether then when we are having this and this condition, so we say B is equal to C. When we are having this condition, these two conditions we are having, so we can say it is not equal, isn't it? So that's what it says A intersection B is A intersection C, then they are equal, so need not to imply that is there. So your concept will be clear. more that if I use this example, so here you see that set A is what? 1, 2, 3, 4, and set B is 3, 4, 5, 6, and set C is 3, 4, 7, 8. So here 3, 4 is common in all the three. So A intersection B is 3, 4, A intersection C is also 3, 4, but here B and C are not equal. You are having, but it is not equal. So this it satisfies that need not to imply that B is equal to C. To clear your concept, you see the video again without seeing it, or first you go through the video, try to understand the concept, then you attempt the question again yourself.